Okay, here's the second half of the exponentials lecture. This one is going to deal more with application, a specific situation where you use exponentials. But before we do that, let's get back to that e, the natural base e. And I just want you to look at this expression that we have 1 plus 1 over n raised to the nth power, where n is going to be any positive integer. And if I make this table that you see here, as I increase n, and it gets larger and larger and larger, you can see what this whole expression becomes. And you see as it gets larger and larger and larger, we get down to here. And you can only imagine if n is something as large as, say, infinity, that this number is actually going to turn into e. So it's pretty darn close to it, don't you think? So I'm going to take us through this exercise here. Just bear with me, okay? We actually can define e as the limit, and this is limit notation, the limit as n approaches infinity of this expression. Okay, now I know you don't know what limits are. We haven't dealt with those. That's for pre-calculus. But I think that you guys can follow along what we're going to do here. Okay, so just leave that alone for a second. And we're going to talk about money and investing money and interest and compound interest. And if any of you have taken my sister's Intro to Business or Principles of Business class either last year or you're currently in it this year, I think you guys have already talked about compound interest, so this will be a review for you. And if you've not taken that class or you are not currently taking that class and you're confused about what compound interest is, I would suggest you pay her a visit, maybe at a tutorial, and she can help explain it to you. Or you can ask somebody in class that has taken the class from her. Okay, so what we're going to do here is we're going to go through and talk about a formula to calculate the amount of interest that's earned on an amount of money that's invested, and you're given a certain interest rate, and it's going to be compounded annually. So that means that however much money you earn after a year, you get some interest on it, right? That whole new amount, you're now going to recalculate the new interest for the next year, and so on and so forth. So that's kind of what it means to compound your interest. So we get this formula where you say that the amount after t years is equal to the amount that you invest times 1 plus your interest rate, and the interest rate should be written as a decimal, raised to the t, which represents the number of years, t number of years. Okay? Well, sometimes you don't want to compound it annually. Sometimes you want to compound it more times within the year. So what if we wanted to compound it semi-annually, which means you're going to compound it twice within a year, so maybe every 6 months. So what you're going to have to do is alter this formula by taking your interest rate and dividing it by 2, because you're doing it twice, okay? But then you're raising it to the 2 times the number of years, because it's twice each year that you're compounding it, so total you would have to consider the 2 times each year. Okay, so we would use this formula. Okay, so what if we wanted to compound it quarterly? So we would take our interest rate and divide it by 4, since that means it's compounded 4 times within the year. And then it's going to get raised to the 4 times t, because every t number of years it's compounded 4 times. Okay, so you kind of get the picture. You can imagine if we, say, wanted to compound it daily, that this would go 365, right? And this would be raised to the 365 times t. So we can actually come up with a formula depending on how many number of times it's going to be compounded in a year, and we call that k. This would be the formula, and this is what you're going to have to remember. Okay, so you take the amount that is invested times 1 plus the interest rate over k, all raised to kt power. Okay, and we'll see an example of how this works in a minute. But what happens if your interest is compounded continuously? So say not just daily, but say hourly, or what if it was compounded every minute or every second? Or what if it was even like every nanosecond? or something even smaller than that that we just don't have the capacity to understand. It's just compounded over and over and over again continuously. So how would we represent that? Well, k, that means, is turning into infinity. And so whenever we deal with infinity is typically when we start dealing with limits. So let's take a look at this. Okay, I don't expect you guys to memorize this or have to completely understand this. Just try to follow along. We're going to let k become larger and larger so it becomes a limit, like I said. And so we're going to write this as the limit as k approaches infinity of our formula. So we have the principal times 1 plus r over k raised to the kt power. Okay, so we're going to do a little fancy math here, which is what mathematicians always love to do. So I'm going to try to simplify this. And what I'm going to do is I'm going to make a substitution. And we mathematicians like to make substitutions. So I'm going to introduce a new variable, n, and I'm going to let n be represented as k over r. So what that means is that I can rewrite this equation in two different ways. I can cross multiply and say that k equals n times r, or I can take the reciprocal of this and the reciprocal of that, and I can say r over k is equal to 1 over n. Okay, so maybe you kind of see where I'm going to go with this, but I'm going to use these two equations that I just came up with, and I'm going to plug them in over here. Okay, so where I see r over k, I'm going to replace that with 1 over n. And where I see k up here, I'm going to replace that with n over r, or n times r. Okay, I know, I'm confusing you. Just bear with me, you'll see what's going to happen. Okay, so by substitution, this expression becomes this expression. So you can see this got converted to 1 over n, and the k got converted to nr. So if I go back to this whole limit that I'm talking about right here, since I'm going to now replace this with that, I have to change this k to infinity to become n to infinity. Because if you look, this whole expression, there's no more k anymore. So really, it's this number that's in the denominator that we're worried about going to infinity. So it's the n. Okay, so now I'm going to do a little fancy footwork here that you need to understand that with limits, if you are multiplying by a constant, you can pull that in front of the limit. Don't worry, you'll learn all this next year. Okay, and then using my properties of exponents, if all three of these are multiplied together, I can rewrite it as this whole thing raised to the n and then raised to the RT power. So maybe some of you have already picked up, but if you recall, this whole thing right here, the limit as n approaches infinity of 1 plus 1 over n raised to the nth power, do you guys remember what that was defined as? It's e. Isn't that cool? So look, you can replace this whole big messy thing with the irrational number e. And we get this new formula, p times e raised to the RT power. And we all kind of affectionately call this the PERT formula. Not like the shampoo, but the formula to calculate interest when it's compounded continuously. Okay, I know, confusing, but really you just need to memorize this formula. You don't need to memorize how we got the formula, okay? I just think it's cool. All right, let's take a look at how we're going to use these things. Here's an example. It says our principal is $1,000. That's the amount that we want to invest. Our interest rate, wow, the bank is being generous. It's giving us a 6% interest rate. It says find the amount after 5 years if the interest is compounded A, annually, B, quarterly, and C, continuously. All right, let's do the annually first. So if it's annually, that means it's only compounded once in a year. So we plug in our principal, which is 1,000, 1 plus our interest rate, which is 0.06, and it's 5 years, so it's raised to the 5. We don't have to divide by k because k is 1. And so this is what it comes out to be. And since we're dealing with money, we're going to round it to 2 decimal places. You should double check that you've entered everything into your calculator correctly and got this answer. You just have to make sure that everything is inputted correctly into your calculator. Okay, let's do B, quarterly. So now it's compounded 4 times within a year. So we're going to take our principal multiplied by 1 plus our interest rate divided by the number of times it's compounded. raised to that same number of times it's compounded times the number of years. So 4 times 5. Don't forget to multiply those together. Okay, so you can see it's slightly more. All right, so now let's take a look at what it would be if it was compounded continuously. And this is where we have to use our PERT formula. So we're going to do our principal times E, and this is where it gets different because we're multiplying by our interest rate up here as the exponent, times T. So 0.06 times 5, and that's what you're raising E to and multiplying by 1,000. And you can see that, it's about $3 more. And yeah, in the grand scheme of things, with you're only investing $1,000, it's not that big a deal. But imagine if you were investing like $1 million. This would be a big deal. Okay, so there you have it. Most of your worksheet that you're going to be doing is going to be just calculating using these formulas. Okay, so make sure that you have them written down somewhere so you can reference. Alrighty, that's it. See you later.